Hello, everybody. Welcome to Workshop 3 in the DSGT Udemy Bootcamp series. So in this workshop, we're going to be talking about Introductory Data Preprocessing. So some of the learning objectives we have in this workshop are four things. One, conceptually understand machine learning. Number two, three ways to conceptualize model and data. Number three, understand the difference between classification versus regression. And number four, which is one of the most important objectives from this workshop, is being able to pre-process your data sets. So let's kick it off. So first off, to start anything, we need to access the Titanic dataset, which we've been using in workshop 2. So first we're going to essentially run this code to set up our imports. And accessing the Titanic dataset should be really easy, as the file right here, titanictrain.csv, should exist in your workspace. So that takes care of that. So what is machine learning? So machine learning is simply a fancy word for saying turn data into actionable knowledge for task support and decision making. So we have a problem. We want to take a data set. We want to use that data set to develop insights, and we want to use those insights to solve problems on other data sets. So we're trying to turn data into action. So that's what machine learning is. And there's two types of machine learning: supervised learning and unsupervised learning. So unsupervised learning is mainly for data exploration. So some examples are clustering analysis, dimensionality reduction, and kernel density estimation. On the other hand, supervised learning is for predictive analysis. So examples of that include linear classification / regression, neural networks, tree-based models. And we'll talk about about this in detail in the next workshop. But I just want you to get a sense that machine learning can be thought of as unsupervised and supervised learning. So these are the two types of learning. So there are three ways to consider ML models. So we have pictorial representations, which is via a picture. We can have decision boundaries as a representation, and we also have mathematical representations. So a pictorial representation, a way to simply understand this representation is which picture corresponds to what algorithm. So we have three images here and three different algorithms. Try to take an educated guess as to which picture you think corresponds to which algorithm. So I'll leave you like 5 seconds to make your guesses. Yeah, hopefully you have your guesses in, but just a spoiler alert, this guy here is a neural network, this guy here is a decision tree, and this guy here is a support vector machine. We'll get into more of what these are like in the next workshop. So the second way to conceptualize machine learning models is through decision boundaries. So decision boundaries are just a way of visualizing how is your ML model making decisions. So how is the model making decisions? And in supervised learning, in classification, we can use decision boundaries to determine which class a given instance belongs to, right? So these are examples of decision boundaries. So you can have simple linear decision boundaries. You can have grid-like and square-like decision boundaries. You could have even complicated functions like this as decision boundaries. And in this case, we're separating the circles from the triangles. So the third way of conceptualizing machine learning models is through mathematical formulations. So what we want to well the way to think about this is that you have a data set, right? And we have something called features, and we want to predict a class, right? So we're taking features as our input, and we're getting an output in the case of classification as a label, right? So if we have input and some expected output, machine learning mathematically can be thought about finding that function that maps your input to an output. So i.e., find that function f such that you can take in an input and get an output y. So take in an input x and give output y, right? So this is a good example. So you have this image, we're going to apply a function to it and then get a label, right? In this case, a jellyfish. So you can think of like different types of problems as classification versus regression problems. So regression problems are predicting a continuous output from input, right? So for example, predicting the price of a house, right? And the goal of ML is essentially to adjust these parameters to optimize performance. So just to recap, classification versus regression are two key problems within machine learning. So classification is predicting a label, so for example, spam or ham, whereas regression is more of predicting a continuous output, so like predicting the price of the house or predicting a rating. So that's just a brief conceptual overview of machine learning. We'll go into more depth in the next workshop, but till then, see you in the next video.